Hello, welcome back. In this segment, we're going to apply the concept of arrays that we were looking at in the previous segment. We have three specs in this, similar to how we did it with repetition selection. And I'll show you the spec, and then what would be a good idea is if you try to solve it yourself or think about your solution, sketch a solution, and then follow along with me as we develop the solution for each of the specs. You'll see that the programs that we can write are getting more and more interesting each time we add something to the language, and in particular, we can solve more interesting problems using arrays. Let's have a look at the first spec now. Here's our first spec that uses an array. We're going to ask the user to enter 5 rainfall values in inches, and these will be double values. And then we will read those values into an array, and we'll find the total and the average rainfall for those 5 days. So we're going to output the total rainfall and the average rainfall based on the 5 values that are entered by the user. So this is a fairly simple exercise that manipulates values in an array. Let's go immediately to the development environment and take this simple spec with us and exercise using an array of double values. So we have started a new project in Visual Studio, and I want you to go and type along with this, with each of these examples. It just makes a lot more sense to you when it comes off of your fingers instead of just watching it come off of my fingers. I'm not really sure why. So I'm going to flip back and forth to the spec. So here is, the spec that we're working on. We're going to ask the user to enter 5 rainfall values as doubles, and we're going to find the total and average rainfall for those 5 days. So let's put a comment in here that says what we're going to do. So remember that a block comment before a function is a good idea so that you can remember what you were doing the last time. So ask the user for 5 rainfall values. We'll store them in an array, and then we'll find the average. What was the spec? Let's go back. The total and the average for those 5 days. So the first thing I want to do is to use a defined constant. So we're going to define the number of days that we're going to use to be 5. And now we can, when we declare our variables, including when we declare the array, we can use that defined constant for the size of the array. So let's make a place to store the rainfall values, and I'll say that this will be an array of double values called rainfall, and I'm going to size it by using the defined constant days. Be careful that you don't put a semicolon at the end of the define. That will cause a compiler error. And what I want to encourage you to do is to compile your code quite frequently. So if you type in all the code and have 25 errors, then it's quite difficult to find them all. But if you type in one line of code and you have one error, it's pretty easy to guess where that error might be. So make it easy on yourself. It doesn't cost anything to compile your code frequently. So let's just do that. And for purpose of demonstration more than anything else, I think maybe we would initialize the elements of the array to 0.0. We don't need to do that in this case because we're going to read values in from the user. So let's find out now what other variables do we need. I should have made an IPO diagram for this. There. an IPO diagram would help us to understand the code, and to work from it would be a little bit easier. So we're going to have a variable called total. It's a double, so let's initialize it to 0.0. And another double variable called the average. And we don't need to initialize that one because we're going to just add stuff into it. So F7 is the shortcut key for compiling the code. And if you compile the code frequently, make sure you still get that one succeeded thing going on down there so that you don't get into a big mess that takes you a long time to figure out. Okay, now what do we want to do first? We want to ask the user to enter the double values that will represent the rainfall. So how will we do that? We want to do something 5 times, so let's make a for loop. And for loops need a variable, a control variable, which almost always will be an integer. So I'm going to declare an int I. We don't have to initialize it because that's what we do in expression 1 of the for loop. So I'm going to write I get 0, semicolon. And how many times do we want to do this? We want to do it days times. So I'm going to write I is less than days using the defined constant and add 1 to I. So the first time through this loop, the value of I will be 0. So each time through the loop, we're going to ask the user to enter a rainfall amount. A rainfall amount for day. What day will we ask it for? %I, colon, so we'll tell the user we're going to ask the user for a rainfall amount for a specific day. I'm going to put I plus 1 to output to the user because users generally don't talk in terms of 0 through 4 when they count to 5. They talk in terms of 1 through 5. So I'm going to output the value I plus 1. So the user will see enter a rainfall amount for day 1. And I'm going to put a carriage return at the beginning of that line, just to make it neater in the output. Now there's the prompt, and now we'll scan in the value that the user enters. And remember that you cannot use a format specifier on input on a scanf like %.2lf. Those are for printfs only. So we're going to read it into, let's see, ampersand rainfall sub I. So the first time through the loop, we'll read the value into rainfall sub 0, and then rainfall sub 1, and so on. Okay, because it doesn't cost very much, we're going to compile this again, see if I've made any errors yet. Nope, 1 succeeded. So why don't we run this, even though it's not done, and see if we have, up until now, apparently a program that's running. So enter the rainfall for day 1. I don't remember what the numbers were, but I'll just make some up. For day 2, for day 4, for day 5. I don't much like that there's no space in between this. So this looks kind of confusing with a number and a colon and another number. So other than that, it seems like this program is working okay. So I'm going to put some space here on the output so that it will just separate the presentation, and it might be a little bit less confusing for the user. So I'm going to put a breakpoint here now, and I'm going to run this program again. so that we can watch in the debugger what's going on. Three 3.4, 3.3, 3.2, 3.1, 3.0, and we've hit the breakpoint. Now what I wanted to do is to look at the array. I'm just going to pop that open and see that the values that we wanted in the array are actually there. This might be a surprise to you that the first time we entered the number 3.4 and we got 3.39999 repeating, and 3.3 is internally represented as 3.29999, and so on. Remember that double variables or floating point variables in general are approximations. That's a surprise to people, but when we enter 3.4, we get 3.39 repeating. That's as close as the computer can come to the value 3.4. Our total has 0 in it, the average has junk in it, and the control variable I has 5 in it. Okay, let's push F5 again to allow that to finish. And what do we want to do now? We want to find the total and the average for those 5 days. So let's make another loop. I'm just going to copy that one. And in this loop, I'm going to find the total of each of the elements in the array. So I'll write total gets total plus rainfall sub I. And I'm not typing too well today. And the first thing that you might see about this is that we could have used a shortcut operator the compound assignment operator instead of writing this out in long form. So when you get comfortable with it, you can start writing that as total plus gets rainfall sub I. This is the operator that's used plus gets very commonly for accumulators. So total is an accumulator variable, and we're going to each time throw this value into the bucket. The bucket started as empty, 0.0, and each time through the loop we added in one of the rainfalls. That's a good analogy, this example, putting the rainfall in the bucket, and then we see what's in the bucket after all the rain. Okay, now let's calculate the average. Average gets total. What do we want to divide it by? How many did we have? Well, we had days of them. We had 5 of them, and now we can output. That's all we have left to do, is to output I must be tired today, I can't type. The total rainfall is %. How many places past the decimal do we want this time? Oh, let's put 0.1 LF. You have to be careful about the difference between a 1 and an L. Costs a lot of time to make a mistake like that. %.1 LF and a carriage return will output the total rainfall, and now let's output the average. It might make sense to output 2 places past the decimal on this one. Okay, let's compile that with F7 and see if everything is still working the way we hope it does. Oh, okay, so it's compiling. And here's the code in case you're behind in your typing. I'll make sure you can see the whole thing. Let's run this using these numbers 0.3, 1.2, 0.0. Zero 0.3, 1.2, 0.0, oops, 2.8 and 0.6, 2.8 and 0.6, and I have the total rainfall is 4.9 and the average rainfall is 0.98. I wonder if that's what the expected result, and it is. Good. And we have hit a breakpoint. Here are the array values. Here's the average, 0.9. Oh, look at this. 0.9799999. And when we output it with 2 places of accuracy, we have 0.98. So there's something very important in there. The presentation of the data using the printf statement is not exactly what's in there. It presented 2.2 places past the decimal, and it did a rounding there. That's the first time I think that we've demonstrated that. So F5 will continue past the breakpoint and allow us to continue. Before we leave this example, there's only one more thing I wanted to point out. Using this defined constant, we could now change this one piece of code, and this code would still work for a different number of days. So if I said, now I want to do 7 days instead of 5 days, all of this code would work correctly. At recompile, we would now be declaring an array of 7 elements. We would loop through an array of 7 elements. This loop would total the 7 elements in the array, divide by 7, of course. So defined constants are very good to allow you to modify your code to make it reusable, modifiable, all of those good things that make software more valuable. Okay, let's have a look at the next spec. Well, here's our next spec. This one will just be a little bit more interesting. We're going to ask the user to enter some test scores, and there'll be 10 of them this time. So our objective is to read 10 integer values into an array, and we're going to calculate several things about these numbers. We're going to calculate the average score, and then we're going to count how many of the students have passed this particular test, where the pass mark is 70%. So we'll loop through the values in the array, and we'll keep a count of how many people have passed. So optimistically, here's a test case that shows the class average of 81.5, and we count that 8 students have a grade of 70 or above. So let's take this spec now into the development environment. It won't be too much different from the previous one, just more exercising, looping through array values and doing something with the values in the array. Well, I've started a new project for this next spec. Recall that we're going to use test scores this time, and the pass mark on this test is 70%, and we're asked to calculate the average score of the grades and how many of the students, count how many of the students have passed this test. So let's define a constant. How many scores are there? What will we call this? Scores count. I don't want to call it scores because 10 is not the actual scores. 10 is the number of scores. So let's now declare an array of scores. So that's where we'll use the name scores, and we'll declare that there are scores count of them. So I'm using the all caps format for the name of the defined constant, and that's just a convention. It makes things a little bit more readable. When you have a problem, you know where to start looking for it if you know that you have a constant. And I'm not going to initialize that one. What else do we need? We need to calculate the average score. Well, what data type is the average of some ints? I claim that the average probably should be a double. If you don't want me to use double there, maybe you would agree that your grade for the course should be rounded down to the next lowest integer. You probably don't want that, so let's declare the average to be a double. And what do we need to calculate the average of the scores? We need the total of all the scores. And what data type would we use for that? Well, what is the total of some ints? What data type? If you add two ints together, is there a decimal point in the result? Well, no. So let's declare an int total and initialize it to 0. Okay, similar to what we did in the last one, we will make a loop that will allow us to ask for all of the scores. For I gets 0, I is less than scores count, I++. Whenever you make an open brace, make the closed one to go with it. Whenever you open something, make the closed one that goes with it so that you don't forget about closing them and then wind up with a bunch of compile errors that are hard to understand. So we're going to prompt the user, enter the score for student. I'm going to do this one the same way that I did the last one. This time I know enough to put some spaces there. And we're going to use I+1. And then we'll scan in the score for that student. So that will be ampersand scores sub I. We want I to go from 0 to less than scores count so that we don't go off the edge, the end of the array. So let's compile frequently. Oh good, I have finally a compile error. Whenever you get a compile error, what I do is in this big mess of text down here, look for the word error and go and double click on it. And it will point at what might be helpful to you. This one is easy. It says I is an undeclared identifier, and sure enough, we didn't declare the variable I. So let's hit F7 again, and that looks better. We have some warnings that there's variables that aren't used, but we won't worry about that because we're not done yet. So the user has entered 10 scores and we put them in the array. What else do we need to do? Well, we need to calculate the average score, and then we're going to count how many people have passed the test. So let's make a loop that will go through each element in the array. This should start to get easy. In fact, we'll just use a cut and paste for that. So we need to total the values in the array. Total plus gets scores sub I. And where do we want to calculate the average? We could do it here. We could do average gets. And the problem with that is we only need to calculate the average once. If we do it inside the loop, we'll calculate the average for every intermediate value of total. So if you only want something to happen once, make sure that it isn't inside the loop. Let's move that down outside the loop. Average gets the total of the scores divided by how many there were, and there were scores count of them. And there's a bug in that line. What is the bug? Well, as we're working on code that uses a lot of values, what I would suggest is that you walk through it and see it work. Now, walking through this code just to find a small error would take quite a while because there are 10 of them. Well, instead of 10 here, why don't we for now change it to something that's more manageable? Let's say we're going to work with 3 numbers, and we'll use something really simple like 5, 7, and 8, and we'll see what's going on with this code. So I'm going to set a breakpoint here where we calculate the average and see if we can't run this code and see what's wrong with it. So compile often. Make sure that your program is working all the time. So if we say, just use simple numbers to see this working, 5, 7, 8, and we've hit the breakpoint. So that was a good thing that we used that defined constant, because now we can change the code really quickly. So the total is 20. Does that make sense to you? 5 plus 7 plus 8 is 20. Good. Let's pop open the array and see if the values we expect to be there are there, and they are. And now we're going to calculate the average. Remember that F10 will execute 1 line of code. I'm going to use these buttons. This little one here is step over, which means execute 1 line of code. So let's execute that line of code, and we've calculated the average, and here's the problem. The average is 6 when we divided 20 by 3. Well, 20 by 3 should be 6 and 2/3. It shouldn't be 6.0. So here's the bug, and it's quite common. We have an int total and an int, this is a defined constant, which is right now 3. So we have an int divided by an int. There are different ways to fix this. Some people would say, well, why don't we total the values into a double variable, so then we would have a double division. That's the wrong answer. It's an answer that makes the program work, but it's not the right answer. When you sum some ints, you should have an int. So what we're going to do instead, you should remember from a previous segment, we're going to upcast the int total to be a double. So for the purpose of evaluating this expression, this will be a double, and it will be divided then by an int. So that int will also be promoted to a double, and we'll have a double division. So let's run this again quickly now that we've made a mistake. I'll turn off the breakpoint, And let's run this with the three small numbers, 5, 7. Oh, well, we won't be able to see the result because I didn't do any output statements. I wonder if I can turn on a breakpoint while it's running. I think so. 5, 7, and 8. Good, we learned something. You can turn on a breakpoint while it's running. So we have the same situation we had before, 5, 7, and 8, and we want to calculate the average, and we have 6 2/3 with some degree of accuracy. Good, let's go back and see what we have left. Well, we calculated the average score, and that seems to be working, at least for those three simple numbers. Count how many of the students have passed the test. Okay, so we need to have a way of counting how many people passed the test. The pass mark is 70%. Well, let's make a variable to count the number of scores that have passed. Passing scores, and I'll initialize that one to 0. And now we want to somewhere check and see if a particular score has passed and add 1 to the passing scores. Well, I could make a new loop and loop through each of the values in the array, or I can just kind of reuse this loop. While we're totaling, I can put a test in here to see if each score, scores sub I, is greater than 70. Is that the operator you want there, greater than 70, or do you want something else? If the student scores exactly 70, do you want to add 1 to passing scores or not? Let's use plus plus, the increment operator. If scores sub I is greater than 70, add 1 to the passing scores. Let's put greater than or equal to 70. Okay, I'm going to do one more thing in here. It's usually considered kind of a bad form to put your defined constants, or sorry, to put your constants into the code like we did here. So it makes the code more difficult to work with. So what it would be a better idea is to define the passing score up here. Suppose someone decides to change the passing score later on. It would be a whole lot easier if we compared each of the scores to a defined constant. So here's what we have inside this for loop, where we're looking at each of the scores, each score sub I. We're going to see if score sub I is greater than or equal to the passing score, and if it is, we're going to count that. So after we've done all of the calculations, then let's output the result. And we'll output the count here. Let's put %I students passed. Maybe I should go back to the spec and see if that's what we were supposed to output, because I really can't remember right now. That's the next one. How many passed? Oh, yeah, the class average is... the class average is what the spec asked me for, so I should do what the spec says. class average is, output the average, and here's a bug. Output the number of passing scores. I hope you're compiling more often than I am. I kind of know that I haven't made any compile errors. I don't expect you to know that you haven't made any compile errors. Let me make some room so you can see all of the code so that you can flip back and forth a little bit and make sure that yours is compiling. Okay, let's run this with 3 values and make sure that we get something that seems reasonable to start with. So if the scores are 80, 70, and 65, the average is 71 2/3, and how many people passed? 2. There are 2 passing scores. So that seems to be working right for a small number. And now when we push F5 again to allow that to finish, when we go back to finish the problem, we will put it back to what the spec said, that there's going to be 10 scores instead of the 3 that we were using to test with. And all of these things will work correctly because we're using the defined constant. So scores count becomes the divisor here in calculating the average and so on. So there are no literals in here. We've used defined constants, and we've manipulated the values in the array using this for loop, which goes from 0 to less than the number of scores there are. So run yours with the test data and make sure that you have the expected result. And here's our third spec for this section where we work with arrays. This one uses 2-dimensional arrays. So in this example, we have students and quizzes. So we're going to have 4 students and 5 quizzes. How do you spell quizzes? That doesn't look right. That's okay, we'll go with it. So what we want to do then is to find the average score for each student. And we want to find the average score for each quiz. A 2-dimensional array where we'll have 4 rows and 5 columns, where each row will represent the student and each column will represent the quiz. It's a good idea to draw a little sketch of this while we're thinking about the problem so that we'll be able to make our loops correctly. This problem is probably a little bit more difficult than what would be expected that you would be able to solve in a concepts class, but probably not more difficult than one you would be able to analyze. So I want you to type along with these, with this particular one especially, and make sure that you understand it as I solve it, and then you'll have at least the concept of a multi-dimensional array, in this case a 2-dimensional array, even though you may not be, you probably will not be asked to solve a problem of this degree of difficulty. So let's just review it for a second. 4 students, and each have taken 5 quizzes. The average of each row in the table and the average of each column in the table. That's what we're going to look for. Well, I've started a new project. This one is the one using the 2-dimensional arrays. And I'm kind of hopeful that I'll mess up a little bit and have to back up and fix things because I'm not really demonstrating to you the process that you'll be using when you're writing this code. And if you're frustrated by the fact that your code doesn't work as fast as mine does, you have to remember that I've been doing this for 30 years. So it's really it's kind of like those cooking shows where they take the cake out of the oven that was already made beforehand. And I know that that's not too realistic. So here's the spec for this one. We have 4 students who have each taken 5 quizzes. So we're going to make a 2-dimensional array that represents in the rows. Each row will represent the quizzes for a particular student. So draw a picture. The first thing I'll do is define 2 constants. The first one is the number of students I have, and I have 4. And then I'll define the number of quizzes I have. I'm pretty sure you spell quizzes with 2 Z's. I have 4 students who have taken 5 quizzes each. So I have a table now. I'm going to define a table of ints called scores. I used that the last time. Maybe I shouldn't use that again. I'll use quiz scores. That's a little more descriptive anyway. Quiz scores, and the number of rows will be students, and the number of columns will be quizzes. There's nothing in the C language that says the first dimension is rows and the second one is columns. But if you don't do it that way, no one will work with you, because this is hard enough as it is, talking about rows and columns. And if you don't use that convention, it will just make things much more difficult for people trying to read your code. So let's start from there. And we want to find the average score for each student and the average score for each quiz. Well, first of all, we need to get some numbers into that 2-dimensional array, and I could ask the user to enter them all, but I'm not going to. I'm going to use the initializer for the array, and this is the first time you've seen this. When you initialize an array, you use the braces. When you initialize a 2-dimensional array, you need nested braces. So the first row will go here. The second row will go here. And these are comma separated. I'll make this. How many rows do we have? We have 4 rows. And each row has 5 columns. So let's make some pretty easy stuff in here. The first student has 90 in all 5 quizzes. And the second student will have 90 in the first one, then 80, then 70, trying to make some numbers that will be relatively easy for us to understand if the program is working correctly. Keep things neat. So the 4th student will decrease by 5 each time. 70. Okay, this is fairly complex, so let's compile and make sure that we haven't missed commas and braces and all of those things. So I didn't. It's fairly unusual if you can type one of these things on your first try and not have a compile error. So why don't we just start from there, and let's look at this in the debugger. We have only done one thing so far. We've declared a two-dimensional array and we've initialized it using this nested set of braces. But I'd like to make sure that that worked. So let's look in using the debugger. So here's our array, and it is known to be of 4 rows and 5 columns. So here is quiz scores sub 0, and it has 5 elements in it. So let's open that one. Quiz scores sub 0 has in it sub 0, which has 90, and up to sub 4, which has 90. So there are 5 elements in quiz scores sub 0. So in a two-dimensional array, you have 2 subscripts, the row and the column, and in the debugger we see each row represented here as an array of 5 elements. Is that kind of making sense? Here's the second student in row 1, which has the values 90 through 50. So I'm going to push F5 to allow that to finish. So now what do we want to do? We want to find the average score for each student. So the score for this student, the average score for that student, is going to be 90. That's pretty clear. If he scores 90 all the time, he has a pretty consistent average. So I need, what variables do I need? I need a total, and I'm going to be specific this time. I'm going to say that this is the student total. Using camel case. Now, if that were an array, a simple one-dimensional array, I would loop through the array and sum up all of the values in there. And that's what I have to figure out how to do in this two-dimensional array. So instead of using a control variable I, this time I'm going to use a control variable for the loops called row and column. Row and col. Now I want to make a for loop that says for each column in row 1, for each column in this row. So let's do that first. For column gets 0, column is less than, what is this? The number of quizzes. So this is student 1 who has taken 5 quizzes. So let's use that constant right there. And increment column. And now we have a for loop that loops over each of these things. What do we want to do? We want to make the total. So we'll say total, no, I called it student total, plus gets what? Quiz scores for this student for each column. So I haven't put anything in here yet. So what we have so far is we're totaling up for the student looping over the columns. So this goes 0, 1, 2, 3, 4, 5. But what goes here? Well, if we put a 0 there, we will have achieved the goal of totaling the quiz scores in the 0th row. So let's start out with that. Let's say we've made a total of these values, and we'll find the average. Now I need another variable to store the average, and I'll call it student average. And the average for that student is the student total divided by the number of quizzes, and we want that to happen in double. Okay, so far so good. Let's run this in the debugger. I'm going to put a breakpoint there so we can step through this code and see if this loop is really doing what we want it to do, adding up all of those 90s. So let's run to that breakpoint with F5. Here are the quiz scores. For row 0, which we're going to use row 0 only, so I'll open this one. Student total sub 0, sub column is 0, so the first time through the loop, column is 0 and the total is 90. Let's keep going. Now when column is 1, the total is now 180. So we're adding in all of those 90s, and there should be 5 of them. I think that's 450. So now column is 5, the loop is over, and we're going to calculate the student total divided by quizzes. Well, there were 5 quizzes, so the student total should be 90.0. Okay, so this seems to be working. We have a program that calculates the average of student 0. But it's not what the spec said. The spec said the average for each student. Well, we have a piece of code that works for one student, and we need to do it for each student. There was a clue in there. We need to do this same thing for each student instead of doing it for student 0. So let's put this whole thing inside of another loop. So we'll say for row gets 0, row is less than students, row plus plus. Okay, so I haven't changed anything in here yet. I just said, let's do this for each row. So I have to change only one thing. I have to change this 0 to be row. Okay, this is a nested loop. We have a for loop that goes through one row of the table, and then when it's done with that row, it will increment the row variable and it will go and do this row in the table, and then the next row, and so on, and it will do it students times. So let's put a printf statement in here that says that student percent I has average percent 0.2 LF carriage return. So which student are we talking about? We're talking about student row, and we want to output the student average. The only way to get comfortable with working with nested loops and two-dimensional arrays is to watch it in the debugger. Well, it's not the only way, but it's a really efficient way. So we're in row 0, and we're going to start with column 0. So right now, quiz scores sub 0, sub 0 gets added into the student total. So watch the behavior here. We're going through each column, so that means we're reading across the first row of the table, and we're adding up the grades for the first student. We did this before. Row is still 0, so this loop has to complete before it finishes. Before we get outside of this loop at all, we have to have dealt with all columns in the table. And now we calculate the average for that student. And that student, you'll recall, had an average of 90 because all the grades were 90. Now what happens? We go to row 1. So row 1, and we're going to do the same thing for the second student. We're going to add all of the students' grades. So we're going across the table. We're adding up each quiz for that student. And we find out that that student's average is 160. Good, there's a bug. How did that student get to average 160? When I know for sure where row is 1, here's the data, 90, 80, 70, 60, 50. The average for that student should have been 700. Okay, work backwards. What is the student total? 800. How did the total for that student's grade get to be 800? Are you seeing the answer yet? I hope so. I'm so pleased that I finally put a bug in some code so that you can see that people don't just sit down and type this and have it correct. The debugger really helps people to see what their code is doing. I quite honestly didn't rehearse this. I have a bug in here that I didn't see until right now. So I've averaged 800. I've taken 800 divided by 5 and gotten an average of 160. Okay, this square says stop debugging. So when you find that you have a bug and you need to go back to the code and change it, you can just stop the whole thing. And let's go back in here and initialize the student total variable to 0. So we actually added both students' grades together. And that's why the second student's average was too high. Very good. Let's run to that breakpoint again. See if we fixed anything. And we can start watching the behavior. We can go faster this time because we kind of are more comfortable with what's going on. So this student, remember, has a total of 450, and then the average works out to be 90. That one is working. We'll spit it out to the screen. Go to the next row of grades, which is the second student. Initialize the student total to 0. That's important. That was the bug the last time. And now start adding each of the columns. So we're adding each of the second student's grades. And we have a total of 350 and an average now of 70. That makes sense to me. If the student scored 90, 80, 70, 60, 50, the average is 70. Going to the third row, sum up each column. This one is not quite as easy because the numbers add up to 440. 90, 89, 88, 87, 86. I think the average this time should be 88, shouldn't it? Well, that's good. And now where row is equal to 3, we have 4 students, 0 through 3, and we're walking through adding up the last one's grades. The debugger will show you everything that's going on. There is no way for it to hide anything from you. Your data is your data. You get to see it on each line of code. And row will now go to 4, which will end the program. So we've added each of the students. We can flip out to the output window and make sure that things are happening here. Well, I left this as student 0, 1, 2, and 3 instead of adding 1 because I thought I didn't want to confuse you too much. Normally the output would have something more human readable than student 0 has an average of 90, but I wanted to use the actual index here, hopefully to avoid confusion a little bit. And if I just push F5 there, it will allow that to finish. Okay, what's left in the spec? We just calculated the average score for each student. Now the average score for each quiz. What is the average score for this quiz? Well, we're going to add up the 90s and output an average of 90. And then this quiz has a slightly lower average. And this quiz has a slightly lower average. So there are 5 quizzes. Each of the columns represents a quiz. And the spec is now asking us to calculate the average of the quiz for each of the quizzes. I'm going to start this one, but I'm going to leave most of it as an exercise for the reader. If we think about what we did the last time, we made a loop that went over each column and we calculated the average for that student. This time we're going to make a loop that goes down and we'll calculate the grade for that quiz. Okay, for each of the quizzes, add them up. It might not be obvious to you, but we're going to need a for loop inside of a for loop. And this time, the outer loop will be over the columns, and the inner loop will be over the rows. And we need a couple new variables. We need a quiz average and we need a quiz total. Here's the bug that we had the last time. Quiz total has to be initialized to 0 each time so that we don't add all of the quizzes up together. So there's a start. This set of loops, for each row, we calculated all the quiz scores for that student. In this set of loops, for each column, which represents a quiz, we're going to calculate all the quiz scores for all the students. So quiz 0, every student that's taken quiz 0 will be summed in here, and we'll find the average for that quiz. And I'm going to leave this part as an exercise for you. And it's probably not the easiest exercise in this whole semester, but I think it will be kind of fun to use the debugger and make sure that you are doing everything that you're supposed to be doing to add up those columns and averaging the columns in the table. Well, I hope you enjoyed working out those problems using arrays, and just a few pointers in here. Some of them you've already seen before. I always try to convince people when they're working with data structures to draw a picture of them. As you're coding, you try and keep too many things in your head at once, and the code, it's not only hard to write, but it gets mixed up. So have pictures of what you're working with laying around with numbers in the boxes, and it just makes the whole coding experience with arrays and other data structures a lot easier, and it's not supposed to be hard. If you're finding it that it's a big struggle, then you're not using the right tools to make it easy on yourself, which is part of the objective. Speaking of that, one of the ways of making it easier on yourself is to program progressively. Write a very small amount of code and test it each time, and if you do that, you'll get faster and faster at it, and you'll gradually decide that you don't need to test every line every time you write it, but you can put in a few more lines and a few more lines. But if you find that you're compiling it and you have compile errors over more than 3 or 4 lines of code, then you're not working progressively enough, meaning work in smaller steps. Always have a test case. We've talked about that in the last few segments. And use good variable names. It will make your programs that are complex appear less complex. It's as simple as that. Hope you're still having fun. I'll see you in the next segment.